Okay, hello everyone. So today I'll be talking about power adapters um, and choosing the right power adapter for the device or product that you're using. So this is just the basics of it. So we have two types of power adapters. We have direct current, and direct current is at and alternating current. But first I'll be talking about direct current. So direct current is the amount of voltage that's supplied is just constant. So let's say 5 volts is um, used for the direct current power supplied, and it'd be supplying 5 volts. If it's 10 volts, and it's 10 volts. If it's 12 volts, and it's 12 volts. And it'll just be going in this continuous line. And here's the time. That's the x-axis. As time goes by, it'll just be supplying 5 volts in 1 second, 2 seconds, 3 seconds, 10 seconds, 1 hour, whatever. So it supplies a constant amount of voltage. So that's what it is. And this is a circuit, a DC circuit. So the current is going this way from positive, goes through the resistor, goes here, and then goes here to ground. So that's how a DC circuit looks like. And this is a constant amount of voltage that's just applied. So, and it just completes the circuit. That's it. And AC is alternating current, and this is a little bit different. It doesn't just go straight through. It goes like this. It's positive and negative, positive and negative, and positive and negative. It's kind of like fluctuates, all the way around. It's just positive, negative, negative, kind of like this alternating current. So the way you could graph this out is by on a graph, the y-axis will be the voltage, just like how we had here, and that would be the vertical axis, and the horizontal axis, the x-axis, is time, again, like this, except it's a little bit different. So we have to use a sine wave. So it's a sinusoidal wave, basically, and we'd have to use a sine wave to get that. So I think so. This is period. So this is entire cycle, basically, from here to here. The amplitude is how high this thing is. So I guess the more voltage that is supplied, if it was 12 volts, it'd be about 12 high, and this graph would be like this. It'd be high. It'd be higher like that. So the way this works is like this. When it starts, it's 0. So when you use a calculator, like I'm going to show you here, so 0, and I go to sine, that's 0, right? So this cycle would be pi half, or 90 degrees. So at 90 degrees, I'm going to go here, is 1. So it goes here, positive 1. And then the next one is, it's 180 plus 90. So that'd be 270. Trick. Sine. I'm sorry, this is 90 degrees. That's 1. So after that, it's 180. And that would be 0. It goes back to 0 again. And then it goes to 270 from 90. So from 180, it's 180, right? Plus we go to another cycle, so it's 90, so that's 270. Sine, so it goes negative 1 right here. And then after that, it's 270 plus 90. That's 360. That means the entire cycle was completed. It goes to 0, and that's where it stops. So this is an entire period. So that's for the entire cycle, basically. So it goes positive. It starts from 0. It goes to positive. It goes to positive. then it goes to 0, then it goes to negative, and then it goes from negative to 0, and then it goes to positive here, and then from positive it goes to 0, and it goes to negative. And that's how alternating um, current works on a circuit, on an AC circuit board. That's what you would see. So you have the period, you have the angular velocity, that would be the frequency. So if the frequency was more, then this graph would look more like this, higher frequency. If it was a lower frequency, it would be more like this, right? For higher frequency, it would be kind of like that. And you would use these equations to find the frequency, the period, and everything else, basically. So you don't have to know this. I'm just showing you. But if you were an engineer or something, then you would have to know this. But I'm not going to go into this in great detail. I'm just showing you how it works, basically, and you have to use math to understand it in a way. So so this is a direct current. The current goes just one direction, and like I said, alternating current, this is the symbol for alternating current. It looks like a sinusoidal wave, like this, basically. And this is the alternating current, direct current. And now we're okay, and this is polarity, and this is basically from positive to negative. So this is center pin positive. So positive to negative, like this. And this is how it would look in the circuit board and the circuit, basically. And this is center pin negative for polarity. And this is positive to negative, and it'd be in this format, from positive to negative. And that's how the circuit would look like. And alternating current doesn't have polarity. And you have to watch out for these symbols when you look for a power supply. Make sure you get the right one with the right polarity. Okay, the next part. So I was talking about center pin positive and center pin negative. So before you to get the right one, you would have to look at the back of your product or whatever you're plugging your power supply into, and it would show that this would be center pin positive, and you'd have to pick the right one in relation to your power supply. So for this one right here, this one is center pin positive, so this would be the right power supply for your product if it was this product right here. And for this power adapter, this says center pin positive, so this is the right power supply for your power adapter. And now we're going to look at something else. We're going to look at amps on power supply. So that's a current for the power supply. So this one supplies 2 amps. So this is not the right power supply for this adapter because it doesn't have the required amount of amperage or current. So for this power supply, it's 12 volts. It's 12 volts. 3 amps. 3 amps. Center pin positive. That's also correct. So this would be the right power supply for this product. And that's all you have to do to pick a right power supply. Okay, now this part, selecting the right type of connectors for your power supply. For most products that you're plugging in your power supplies to, it will have the dimensions of the power connector that you will need, but sometimes it doesn't. So in order for you to measure it, you'll need a caliper, and you measure out the outer shell of this circle, and the outer part of the circle is, for this product, let's say 5.5 millimeters, and the inner part is, let's say, 2.5 millimeters. So the inner part is here, and you would measure that with a caliper or a ruler if you can, and you would get these dimensions. So for this product, you would need C, so that would be 5.5 times 2.5 millimeters. So that would be the right connector for this power supply. And if you don't know what the connector is for the product, I guess you could go to the website of the company that made your product, and they would have these dimensions of what kind of power supply you'd need, what kind of, like how much, all the specifications about the power supply. So you could use the right one, and they would have the connector size of what kind of adapters you could use for it. And that's how you could find out what the connector type is. So for the power supply, you would have to know that as well. For most power supplies, they would have those specifications before you buy it, like how much current it supplies, how much voltage, the type of connector, and the voltage and everything else. So that would be that's what you would have to find in order to find the correct power supply for your product. Okay, I'll be talking about regulated and unregulated power supplies. So what's the difference between the two? So basically, a regulated power supply, this is a type of power supply that will supply a constant voltage to your product, and the voltage will not change basically. So if it's 12 volts, it's 12 volts. If it's 9 volts, it's 9 volts. So for a regulated power supply, the thing you have to watch out for is if it supplies how much amperage your product requires and how much amperage the power supply is pulling from the wall socket. So if your power supply is only capable of 2 amps and your product requires 3 amps, then it won't work, because this power supply cannot supply the adequate amount of amps to your product. So as a result, this thing will be working harder to supply the required amperage, and this could create a fire hazard. The power supply could catch fire if it's overloaded. If it's working harder than it has to, then this is bad. This is going to heat up, and it could catch fire, and that's not what you want. So if this was 1 amp power supply and you had 3 amp was required for this, that's bad, because this power supply would be working 3 times harder, and that would overload it, and that would catch fire, like I said. So for this type of for regulated power supply, it's okay to have more amperage for your power supply. So let's say you had a 4 amp power supply, and the amperage that was required for this is not negative, this is equal. I'm sorry about that. It just looks like negative, but it's equal. So so if 3 amps was required and 4 amps was being supplied by the power supply, this is okay, no problem. If this was 8 amps and this requirement was 3 amps, that would be okay too, because it would still supply, because it's a regulated power supply, it's supplying the same amount of voltage. The voltage does not change basically in relation to amperage. So this is for this, make sure if you buy a regulated power supply, you could get the one that has the exact amount of amperage, but if it's over that, that's okay for regulated. For unregulated, that's a different story. So let's say for a unregulated power supply, I'm sorry, it has to supply the exact amount of amps in relation to what you're using it for, what you're using basically. So if it's 3 amps requirement, then you should pick a power supply that has 3 amps at 12 volts or whatever, if it was 12 volts. So because if the amperage is over it, then the voltage is going to change for this, because this is an unregulated power supply, and that's not what you want. So you want to pick a power supply which is closest to the amperage that is required for your power supply, and that's it. So anyways, thanks for watching. My Ace 1000 KS 1975.